Okay, I'm just going to say a few words then, just for a bit of background and a bit of a call to help. Firstly, thank you to everyone for signing up for this evening's event. And of course, a huge thank you to Venkat for being with us. For those of you that don't know me, my name is Barry Cranford. I'm the founder of the London Java community. I'm not a developer myself. I run a tech recruitment company called RecWorks. So here at RecWorks, we've been on a mission for the last 12 years now to prove that recruitment can be a force for good in the tech industry beyond just getting people jobs. And that's specifically around learning, mentoring, and career development, and that kind of thing. So put simply, we aim to create groups and platforms where we connect people that want to learn with others that want to share. And that can be on a group basis, like today, getting a chance to learn from Venkat, or on a one-to-one level. So the biggest example of what we do is our Meet a Mentor community, which has got really close links with the LJC. So we organize introductions between mentors and mentees at all levels. Been doing it for about 3 years now. We've made over 2,500 introductions and have got 1,700 members there. But we always have new members joining, and this is exactly what we need some help with, which is some new mentors. So if you're open to getting involved, whether it's students, junior CTOs, engineers, or aspiring speakers, then please let me know. I'll put a little link in the chat, and you can find me on LinkedIn or sign up at meetamentor.co.uk. It's all powered by recruitment, so we don't make any money from anything other than getting people jobs. So if you're looking to hire, or your company is, or you're looking for a new role, then please do bear us in mind. Anyway, I'll get out of the way now. On to tonight. And as I say, a huge thank you to Venkat. So he said he didn't want a big introduction. So he is a programmer, an author, and a frequently invited speaker at conferences. So Venkat, enjoy this evening.
Thank you so much. Thank you to everyone for joining. Thanks to Barry and Don for organizing this. And thanks everyone for taking your time and spending your evening or day or morning, wherever you are. I want to talk about something that's absolutely intrigued me, which is collectors. And this is something you could spend an entire weekend on and still have more things to learn about, in my opinion. So that's what I'm going to focus on. And Dom has kindly agreed to take your questions and bring them my way. So fire away along the way. So anytime you have a question or a comment, post them on the chat or the Q&A right away. And you can also ask questions towards the end as well. So let's get started. Well, one of the key things about Java 8, especially that drew my attention, was the fact that we can do functional programming in Java. So in that regard, we can write code using functions like filters, map, and reduce. So these are the functions that are the tools of the trade when it comes to functional programming. So oftentimes we write code with these functions. And of course, a few things we need to keep in mind is these functions have to be really pure. And that's basically one of the key things, is that these are pure functions. We should avoid mutability when it comes to these functions. So let's start with a little example and then explore some of the ideas and thoughts behind it. So let's start with a little example of a collection of people, let's say. So I have a bunch of people at my hand right there, and we have Sarah and another Sarah, 20 years and 22 years old, Bob is 20, and so on. So if I want to really, let's say, get the names of people who are older than, let's say, 30 years of age in uppercase. Well, we know how to do this, so I'll just kind of review that quickly. So create people.stream, where stream is, of course, an internal iterator. We can do a filter, and given a person, we can simply say person.getAge. And of course, we are interested in age greater than 30. We can perform a transformation or a map operation, and then we can get the name of the person. And then, of course, we can simply print it out for each, and we can simply say system.out, and then we can do a print line. Now, in this case, of course, when we do the print line, we're going to print out the names, of course, of the people who are older than 30 years of age. And so we see those three values being printed. So that was pretty straightforward when it comes to writing the functional style code, as we can see in here. However, when it comes to these kind of code, we got to be really careful about immutability. And the worst kind of mutability is shared mutability. And shared mutability is where you take a variable that is, so to use the word, global in scope or available from multiple threads, and then we start manipulating it. Now, I have to say, that this is something we need to be extremely careful about. So what if we want to take these names, but we want to put them into a collection? Well, the first thing I want to start writing here is, please don't do this. And I want to always put a disclaimer when I write a bad code, because you don't want people to accidentally use that as an example. So we write a list of string, let's say names is equal to array, let's say new, and we create an array list over here. Now that's the very first smell, as we can see right there. And then we can go in, and in the for each, everything is going well so far, but unfortunately, we take the name and then we say name.add, and then we can, so let's take the name in this case and say names.add, and then we add the name to it. And then of course, once we add the name, we can come out of this and print out that particular names collection. Now this right there is important to note, is called a bad idea. We should never do this. Now, the reason I emphasize this is, I cannot tell you how many times I've seen programmers do this. Now, I get emails from people all the time. And I remember one time, I won't mention the name of the company right now, a financial company where we all put our money into quite a bit. And a programmer from the company emailed me and said, hey, Venkat, this code worked fine until yesterday, but it quit working this morning. And I didn't even read the rest of the email. I jumped right to the for each in the code he sent me, and I looked at it, and sure enough, there was a mutability, and I said, that's the problem, that's where the problem is. Well, and I keep getting this email so many times, and I'm gonna tell you that I've seen this bad code every single week. Now, when I say I've seen it every single week, I was thinking about it, and this is the funny part. This was the week of Christmas a couple of years ago. And I said to myself, week of Christmas, nobody's going to drop me an email. They're all going to be having a good time. And I opened the code that I had written the previous night, and I was in a panic because I had written this code, and I was telling myself, what went wrong here? And the only explanation I can think of is, it was not me, folks. It was an alien that came in the middle of the night instead of Santa Claus and wrote that code. And I was in disbelief that I had written that code after telling so many people, don't do it. And here I was committing the same exact mistake. So this is so natural that we fall into this trap, and we should really avoid it. And I felt absolutely guilty writing this code. But the question is, how do we really fix it? What are we trying to do really? What we are trying to do here, of course, is this is a shared mutability, as you can see right there. That variable, why is this a bad idea, first of all? Well, the reason is this code may pretend to work correctly. I quit using the word the code works anymore. I only say the code behaves. That's what it really is doing these days. So the problem with this code is, if we ever turn this stream into a parallel stream, then all bets are off. We will run the code, and then we will ask the question, who did we lose this time? Was it Bob or was it Sarah that fell down through the cracks? So we'll enter into a race condition the time we try to do this. So what's the answer? The answer is to really use the reduce function. Now, how do we write the reduce function for that? Again, I want to continue with please don't do this. So what I would do here is I would take this code and I would then say create stream right here, create people. But then what I would do here is a reduce call. And what does the reduce do in this context? It starts with the new array list, which is an empty list, as you can see right there. So that's the first argument, is the initial object we're going to work with, which is the new array list. The second one is going to be, we take the list, but we also take the new name that we have been given to us. And what we're going to do here, unfortunately, because Java doesn't support this nicely, with the return value, add is a void function, is list.add, and then we'll say a name, and we'll return the list from there. Now, of course, you may look at this and say, oh my gosh, isn't that mutability? Well, yes, but it's actually isolated mutability rather than a shared mutability, because that's an object that is coming in this thread that you are accessing, but not across threads. But then there's a last part to this as well, where you take a list 1 and a list 2. And then what you do here is you do something like a list1.add all, and then you add the list2, and then you return, in this case, a list1. Now, the reason why you have to do this last part is, if you were to run this as a parallel stream, you're going to divide and conquer. So you may take these partial lists together and combine the partial list to create a bigger list, and then you have to do this. Now, I'm not going to vouch for this particular code because I always mess up when I write this code, so I cannot tell whether it's going to work or not oftentimes, but in this case, I was a little lucky, it behaved. But raise your hand if you want to write that code. No, I didn't see any hands going up because I know I'm among wise people in the world. Nobody would admit to that and say, I want to write that code, right? Because this is extremely error prone. It's hard to maintain and very difficult to work with. Now, when you have such code that you have to write, what do you normally do? When you have to write code you don't like writing, and especially code you don't want to maintain, what do? Well, that's when you hire the interns, isn't it? And you let the interns, no, I'm just kidding. Well, only a little bit though. But the point here is we don't want to be enduring that pain. We want to delegate. That's the whole point. That delegation is the collect method. So you say collect, and the collect method says, sit back and relax, Venkat. You don't have to work this hard. Let me take care of that for you. And that all that code you see here literally is the to list. But where is the to list really coming from? That to list is coming from the collectors utility class, and that's exactly what I'm going to spend the time on, is that one class that I've been really intrigued by. So collectors is a utility class that returns for us a collector, and the collector is really an interface with different implementations that can be passed to the collect method. So the collect method is working with the collector, which is going to return a to list for us. And when we run the code, you can see that it gives us the proper value. But the beauty of this is, unlike my code that I write here, this one actually is thread safe. And that's the beauty of it. I don't have to endure the pain of writing it and then spend my night worrying about the correctness of the code. That's taken care for us already. So as a result, we don't have to worry about whether it was done properly because it was written by the people with the good hands and good minds, and they knew how to take care of it properly. So in other words, we should never really use mutation in our code. And I cannot tell you how many times I see code where people mutate. Instead, the right way is to delegate that to the underlying APIs. So we can use the to list as we saw, or we can also take this a little further and take this into a set. And in which case we can convert to a to set as well. Notice how quick that was compared to the code I would have otherwise written, which is already error prone, but a nightmare to maintain as well. So we can convert that to a set very quickly as well, as we can see right in there. So we can use these collector methods. But you say, wait a second though, didn't you just say we should honor immutability? Oh, totally, I agree with that. But unfortunately though, with what we have right now in here, we use the toList method, and toList method was provided as part of Java. So when I run the code this time, notice that in this case, of course, I will remove this comment now because this is something we can do. But when I run the code this time, notice that we are getting Paula, Paul, and Jack. But what if somebody takes this names collection and then in this case does an add, and I add a Venkat? Well, Venkat is not supposed to be in that list after all, but what if I add Venkat to that list? And unfortunately, we allowed for mutability on that list once we created it. We don't want that to happen. So what you can do is, instead of that, you can start using unmodifiable list moving forward. So when you use an unmodifiable list, notice we get an error on line number 25, and that's an unsupported operation exception because the list that got generated now is actually unmodifiable. So instead of using the toList or toSet or toMap, we should really move forward to using the toUnmodifiable list, toUnmodifiable set, and toUnmodifiable map, and that's a much better option to use. Now we saw the collectors already providing a bunch of functions, and we just talked about 6 functions after all: toList, toSet, toMap, and toModifiableList, toModifiableSet, and toModifiableMap are the functions we can actually use, which is great. But let's change the example just a little bit to see what we want to do. Suppose the example that the problem we are given to solve is given the list of people, let's say create a string with names in uppercase, and the requirement says, of course, comma separated, and of those, let's say older than, let's say 30. Now, how would we do this using the imperative style of programming? We'd use a for loop to do it. But when you write a for loop, it becomes really messy. Int I equal to 0, and you're like, oh, come on, Venkat, where have you been? You can simply say string name and easily get the person out of it. So string person, create people is the way to really go. Well, great. Then what do? If the person dot get age is greater than 30, gosh, that's great. We got the name. Output the person dot get name, and of course take the name and convert it to uppercase. That was not really that hard, was it? Well, not really, but except that one problem, that when we have this person given to us, what we really want to do, well, create people obviously in this case, and this is a person, pardon me. So in this case, of course, when we run the code, we get the names printed, but it says comma separated, isn't it? So we would say plus comma, but then of course we really know it's got to be on a single line as a string. So we could remove that print line to get it out in a string. But then how do you put that into a string? And even if you do, notice that stupid comma in the very end. Anyone who has seen that problem before? Every single one of them. And you said to yourselves, this cannot be happening to me, right? And you're thinking, how do I get rid of that stupid comma? Or maybe I can remove it from the string. Darn it, string is immutable. And then of course you were like, hey, why don't you put that in a string builder? And your colleague is like, is a string builder or string buffer? And we have a 20-minute meeting about this. And it was supposed to be simple, isn't it? Then one of your colleagues says, I got a great idea. Simply find the last element and don't put a comma for it. Oh my goodness, of course it's easy. How do I know it's the last element? Oh, to know it's the last element, all you have to do is int I equal to 0. And then of course you're like 30 minutes later, this cannot be really happening to us. Well, that's one of the nice things about the collector is we can simply say output, and we can then say create people dot stream, and we can then come to the collect method. And keep in mind, collect is nothing but a reduce function, as we saw earlier. So the collect is a reduce function with the collector as a helper. So in this case, collect what? Well, I want to collect them, but first of all, let's do a filter. Given a person dot get age is greater than 30, then we take the map, and given a person, get the name of the person, perform another transformation, convert to uppercase, but then as a last step, we can say collect joining, in this case, join with a comma, please. And then as a result, when I run the code, you can see that it actually prints them and with no comma in the very end. So that becomes a nice way to write that piece of code. So joining is yet another example of the collectors, and joining returns a collector which knows how to join these things into a string automatically for us, as you can see. So this is one of the really nice, useful functions to quickly join things. Well, okay, that's great so far. But what about taking the collection of data and then splitting them into multiple pieces? So for example, I could go to this collection of people, but then I could simply say, I want to perform a collect. And collect is going to perform with the partitioning by. So partitioning by, and what am I going to partition based on? It takes a function as an argument. So given the age of the person, partition people who are, let's say, older than 30, and those who are not older than 30. So when I run the code, you can see false, those who are not older than 30, and you have Sarah, Bob, Jack, the little one, and Jill, 11. and true, and you see Paula and the rest of the gang who are older than 30, you can see on the right side. So partitioning gives us an ability to split this into two parts very easily, one which satisfies the predicate and the other which doesn't. So this is a very quick way for us to use the collector again. And this is one of the things that intrigues me about collector is it really is a high level of abstraction. So as a result, we can write the code very easily and make it really readable. Now, I do have to admit, it can get a little bit more complicated. And I generally feel that collectors are more easier to read than to write in general. So I put more effort to write them, but it becomes easier to read and work with in general. Now, after all, why do we write code? For people to read, isn't it? So I don't want to optimize my code for writing. I want to optimize my code for reading. So the effort is well worth it, in my opinion, to be able to spend the time on creating it. So that's an example of partitioning by. But I want to just, one more thing I want to provide here is the function grouping. But at this point, when we jump into grouping, I also want to show you something that is pretty darn powerful, and we will branch off and see the power of collector going far beyond what we have seen so far. So what partitioning did was to take the collection and split into two parts, those that satisfy the predicate and those that doesn't. But what if I want to group the people based on some information? So I can call grouping by. Now, before we talk about how grouping by actually works, let's think about what we want to group based on. What if I want to take this collection of people, but I want to group them based on the names of the people? Now, this is a thought experiment you may want to run for yourself. The name is a string, which is a key, and the value is a list of person. And I'm going to say by name is equal to. Now, here's a thought experiment for you. You are absolutely, one of the beautiful things we have in this world is we got world full of friends. If you ask me if there is one thing I absolutely cherish in my life, I'll be honest about it. It's not the technology. Technology is great. It is the friends that I have come across around the world. And I can pretty much walk into a random city and there is somebody there that is a friend for me. And that is what I really absolutely cherish, is the world full of friends. But then here's a thought experiment for you. Think about all your friends, and you might be surprised that most of your friends are there's one name that's the most prevalent among all your friends. And so one day I was thinking about it and said, I've got a lot of friends. I'm very thankful for it. But what is the most common name among my friends? And I came to a sudden realization that my friends, a lot of my friends have first name called Brian. I have no clue why. And so these days, somebody comes to me and says, Venkat, can I be your friend? The first question I ask them is your name Brian? If they say yes, I'm like, sorry, dude, that's taken, right? It's overloaded. I've got too many Bryans already. I was mentioning this in a user group the other day, and somebody was extremely nitpicky. They said, is it Brian with the I or a Brian with the Y? Well, okay, fine. We are a bunch of programmers. What else do you expect? Well, it's a Brian with the I to set the record straight. So I got the most number of Brians as friends for some reason. So maybe you can run that experiment by using the grouping function and then see how many friends of each name that you have. So in this case, I'm going to say create people, and I'm going to say dot stream, and then I'm going to say collect. And the collect function, once we get it, I'm going to just simply output right in here the by name right there. But what is the collect going to do? I'm going to say grouping by, and given a person, I want to return a person.getName. And before I run the code, I want to really think about what's going on here. I wanted to think about buckets. So imagine in front of you, you have several buckets, and each bucket is empty to begin with. And then you are saying, I'm going to take the first person and get the name of the person. And the name of the first person is Sarah. So I'm going to take that person, Sarah, and drop into the Sarah bucket. And the next person I take, get the name, is Sarah, drop the person into the Sarah bucket again. The third person is Bob, and we're going to drop Bob into the Bob bucket. So essentially, all that the collect function grouping by is doing is it is dropping the object, which is the subject, into an appropriate bucket where the bucket identity is provided by the result of that particular call. So when I run the code this time, you can see them all fall into their buckets. The Bob bucket has Bob, the Sarah bucket has two Sarahs, Jill bucket has Jill, and then of course Jack bucket has two Jacks, and so on. And of course, as you know, we could simply turn this into a nice method reference as well. So person double colon get name, and we can make it a little bit more concise in writing that as well. So that gives you an idea about how we can nicely write the code using grouping by, and we can keep in our mind that can help us a great deal is this concept of buckets. So essentially what grouping by is saying is, use this function to provide me the identity of the bucket. And based on that, I'm going to drop this into different buckets. Except for one other detail, this can not only be done sequentially, it can be done in parallel as well, pretty darn correctly and efficiently. So you can go either way, depending on the size of the problem you are dealing with. So that's thread safe as well. And that's a bonus we get out of that. Well, I'm going to start diving a little deeper into the collector API at this point, but now is a great time to pause and see if you have any questions or comments. Keep them coming along the way. We don't have to wait until the end for the questions. Just about any question is a great question to have, so please don't hesitate at all. So if you have any questions or comments, absolutely raise them, and I'll be delighted to answer them along the way. It's not an interruption at all. I'll be delighted to hear what you have to say. So with that said, we can use the grouping function, and as a result, what have we seen so far? All we have seen so far is the collect is a reduce and collector is a helper, where we can do different kinds of reduce operations. So to summarize, what we have done so far is collect is reduce, and there are different things we want to reduce into, and collector helps with that. And collectors is a group of functions, right? Helper functions, to aid us towards that. So that's basically where we are. So I'll pause a little bit, see if there are any questions or comments, and then we'll move forward to the next step.
Yeah, Venkat, there's a couple in the chat. Curious how you're getting the print line to appear as a tooltip.
Oh, yes. So what I'm using here is a very old editor called TextMate. And if you're curious about this, I use TextMate to run Java programs. I use it to run Python, JavaScript, name it, almost any language code. I use it to run it. If you're curious about it, you can go to my website, https://agilelearner.com. You can see my site is Agile Developer, but you can go to agilelearner.com, and there's a search box right there, and then type the word TextMate in there, and you can see a video where I show how you can actually do this. The video itself is free of charge, but you got to register to the site to get access to the video, but you can take a look at it. If you don't find it, not a problem at all. My email address is on line number 3. You can send me an email anytime. I'll be absolutely delighted to point you to where to find it. Just drop me an email. I'll be more than happy to send you the link and see how you can get that as well. So with that said, yeah, so that's TextMate essentially. That's just firing off. And TextMate has a capability where TextMate has no clue what I'm actually doing. So what I do is I take the code and push it to the shell. And on the shell, I run the language compiler, depending on what language extension the file is. and then take the result in the shell and then just simply displays as a tooltip. That's all I'm doing. So nothing really fancy other than just pushing it to the shell and displaying the result back from the shell. Yeah, thank you. Any other questions we can take?
Yeah, there was some. What was the problem with streams versus race conditions? Which
yes.
specific anti-patterns should we avoid as well?
Yeah, absolutely, absolutely. So quickly to visit that, if you had a list of, let's say, integer, for example, numbers, let's say, is equal to new array list, right? And if you had this right in here, what's going to happen is, if you take this code, and if you say, for example, numbers is equal to, let's say, list of, and in this case, list of numbers 1 to 10, if you were to say numbers.stream, and in this case, if you say dot, let's say, just a very simple for each, keep it extremely trivial, and you get a number, and then if you said numbers.add number, now what's going to happen is, this piece of code that you see here, right? So let's think about this a little differently. I'm going to just make this a little ugly. So if I were to run this code, you can see that we are mutating the numbers collection right in there. So when we come back and output the numbers in here, it's going to be literally the same numbers. We didn't do much at all in this example. So we're going to get back that result that we are going to get back in this particular collection after all. So let's say result in this case that we want to add. So results, and this is going to be the results we are adding into, and that's our results. But the point really is, if you were to go back to this code and just examine the thread that is running the code, thread.current thread, you will notice that that line 25 is running entirely in the main thread. That's where it's going to be running after all in this particular code, isn't it? So that's basically where the output is going to be executing that particular code. Execution is going to be in that one line, which is going to be the main thread. I'm not sure why it's not displaying that particular information right there, but it's supposed to give that output of the threads that are running the code right there. So maybe I can run this on the command prompt just to be sure we are catching the output. So if I go back to the directory here where I have the code, so let me increase the font size right there. So going into the Java directory, so I'm going to say Java minus the temp classes. So let's go ahead and compile the sample.java, and that's going to be our Java C, of course. So compile that, and the Java minus class path, and then let's go back and fire that up, classes directory, and run the sample. So we can see, so that's fooling me right there. So let's try this one more time. Let's add to list and pass the name to it. So where's the name sitting right there? I'm capable of making silly mistakes while I type, but we'll figure it out right now. So add to list is going to take a list, let's say, of numbers. So we'll say integer numbers right there. And then I'm going to say this is an int number. And just to illustrate the point, I'll say numbers.add, and then I'm going to just add the number, give a number to it, right? That's all we are doing here, taking the numbers. So that looks pretty benign to us when it comes to just looking at a very silly example of just a for loop going through that, isn't it? So this is simply saying add that to the numbers, and the result of that is going to be just the result we provided to it, which is going to be the number. Where is the number here? There's a number right there, and we're going to add to that. But essentially what's happening in this case is, what about the threading after all? So I'm going to say over here, thread, and let's see if I can display the thread.current thread. So current thread of execution. And I want to just display what thread is going to be executing that particular piece of code. I fail at it today, as you can see. For some reason, it's not showing up. Does anybody know what I'm doing stupid here? So it's not showing up the thread information after all. But anyway, the point really is that's running from multiple threads after all. But on the other hand, what is going on here if we do a parallel stream? Well, that's going to be running from multiple threads all at the same time. And as a result, that code that we write in here is going to be pulled in from multiple threads running at the same time. Well, that's where the thread collisions may potentially happen. And as you don't seem to be executing the stream you are saying. Well, the for each is executing the stream actually. That's why we're getting the result after all. So I need to take a look at what I'm doing stupid. I can't see it yet. So that's basically the point, is that this code is going to be running from multiple threads at the same time. And as a result, in other words, you never want this mutability of a common variable visible to multiple threads being attacked by multiple threads at the same time. So as a result, the result can be really error prone. It's really hard to prove it by running the code, because the code could be running at the right pace, but sometimes it'll just fall through the cracks and you may not get the proper results. So that is something you got to be very careful about. So the short answer is shared immutability, right? So shared mutability is where you have really a variable which is visible to multiple threads, and you don't want multiple threads to be touching that variable during execution. That's basically what you're looking at. So any other questions we have?
Is there any performance difference between a for loop and streams for large sets or large lists?
So the short answer is it is going to be really a wash. The more thorough answer is if you really want performance, I always say, don't give me a faster bicycle, give me a rocket. So if I really want performance, I probably want to go parallel for a large collection. Imperative style code is a beast to parallelize. Only a few people survive that journey. So instead, I would rather make the code into a functional stream, and when I need it, easily parallelize it and get better performance. So this myth that we need to care about raw performance absolutely hurts us. So performance is just one among the trade-offs that we need to be evaluating, and invariably for almost everything I do. Let me put it this way. I worked on a project, which is a big data project. We are dealing with 53 billion computations, and we are using parallel streams every corner you can turn. And we need to quickly parallelize code, and we couldn't have done that without parallel streams. So don't measure the raw performance. The computation complexity is the same. And when you really want performance gains, it's easier to parallelize where it's needed with parallel streams. So we need to really evaluate performance in the context of the trade-off and not in absolute terms. One more question maybe before we move on.
Is there any case that parallel streams is not thread safe? Where we shouldn't use it?
Well, yeah, a lot of places where parallel stream should not be used. We could do an entire talk on it and still not be done with it. I have a talk on the power and perils of parallel stream, where I spent 5 minutes talking about how wonderful it is, and then 85 minutes talking about why not to use it. So the answer is yes. Parallel streams is a can of worms. You open it, and then you have multiple problems to deal with after that. Mm-hmm. So yeah, we have to be very careful. I'm not an advocate of parallel streams without really considering some of those things. Absolutely, we have to be very careful about. Well, okay, great.
Hi, Venkat.
Yeah. Oh, yes, please.
I mean, I have spoken with a lot of the developers, and they have that notion that when you use plain for loop with the indexing, I equal to 0 or I less than or some other limit, but instead of when you use stream, and if you compare the performance, those plain old-fashioned for loop gives us a better performance when you compare with.
Totally. Ferrari is the fastest car I can find. I don't think I want to drive in the middle of Bangalore streets or in the middle of London either. So when is that we want raw performance? If they can convince me raw performance is the measure, I will follow what they say. But that's not the applications I work with. It is never a raw performance that makes a difference for me. So that's why if we are ignoring trade-offs, if you're ignoring context, we get what we deserve. That's the simplest answer. So if you want the fastest car, you get the fastest car for the price you pay, and you can keep it in your garage. you're not going to be able to go drive around much with it. So that's always, it comes back to context, comes back to trade-off. We have to measure things based on the purpose of what we do. We never go home measuring raw performance. I hope that helps to answer your question.
Yeah, sure. Thanks a lot.
Sure. So we talked about.
Venkat, can I just stop you there for a minute?
No, please, fire away.
There's a question I just wanted to ask. What is the right way to handle exceptions in streams?
So what is the right way to light up a cigarette sitting next to a gasoline can? The answer are the same. The reason I say that is, I want to really emphasize it, that exception handling is an imperative style programming concept. Exception handling and functional programming are mutually exclusive. They are mutually exclusive. We do functional programming or we do exception handling. We don't do both. And the reason is this. Imagine a friend of yours calls you and says, I'm driving on the freeway. I have a flat tire. What should I do? The worst advice we can give our friend is drive in reverse and go back to where you came from. And while you do so, blow the freeway. We will never give such advice, be their friends forever. So what do you normally say to a friend who says, I'm driving on the freeway, got a flat tire? You say, dear friend, first exit the freeway safely, but keep moving forward. So we are in a functional pipeline. So when you're in a functional pipeline, something goes wrong here. You want to safely come out of the pipeline, not really blow up the stack. Exception handling is terrible because it's an imperative style programming concept. So you have a exception, treat errors as data and move forward and come out the other way. There are two places to get inspiration for this. One is look at the completable future in Java. Completable future is a functional stream where the stream that you see is really a stream of one data, right? Completable future is not a stream of multiple data, it's a stream of one, it's a pipeline of one data. But what does completable future do? Completable future gives you two channels. It gives you the data channel, but it gives you the catch, which is the error channel. If everything is going fine, you propagate the data through the data channel. If something were to fail, you jump to the error channel and you propagate error through the error channel. Another place to look for this is in the Reactive Streams API. Reactive Stream API is for multiple streams of data, but the Reactive Stream API has three channels. It's got the data channel, the error channel, and the complete channel. When everything is going well, you're passing data through the data channel. Something goes wrong, the data channel closes up and you have an error through the error channel. So we need to rethink about how we model our applications. And so, this is funny to a point of being tearful. I got an email, I'm not making this up at all. I got an email from somebody who said, Venkat, I looked at the JDK and the developers of the JDK did not implement exception properly in streams. So I copied the JDK and I made the stream support exceptions. So here is my library. Can you review the code and tell me what you think about it? And I replied to the person saying, I'll be very happy to, but before that, if you will please ask me one question. Have you asked the question why they didn't implement before you went on to implement it? If you can tell me why they didn't implement, I will continue reading your code. Never heard back from this person again. And that is the problem, right? We want to really use the tools we have to solve a problem, but we got to step back and ask the question, hammer is not the right tool. They tell me to remove the fly out of the forehead of a friend. And so that exception is a hammer. That's not a good tool to remove the errors out of a functional pipeline. So to answer your question is we struggle to really bring that in, but the point is we should really treat error as data and then use really the pipeline to propagate the error as another form of data rather than trying to attack that as exception handling mechanism. So I hope that actually helps to rethink about it.
Yeah, thanks.
Sure, absolutely. So we talked about the grouping by, but I want to take this to the next level. And this is one thing that blew my mind, honestly, and I want to spend a minute on that. So in this case, if I were to take the map over here of string, let's say, and then I say in this case, the list of person, and this is going to be by name, and we got the grouping by. So grouping by, and then I say person get name, and we got the name. So once we print it, we are able to see the grouping by the name. So this is coming from the collectors, as you can see right in there. So when I go back and run the code, you can see that this is grouping the people based on the name, but this is all going to be literally, this is going to be all the collection that we get back in this case. Oh, this is create people, obviously, sorry about that. And of course, create people is a function that I have written over here that I'm going to just bring that over. Great. So with that given example, we are able to get these people grouped based on the name. But if you look at the keys that we have in here, what are the keys that we have? The keys that we have here obviously are really the names of the people. That's what we are dealing with right now. But having the name of the people, let's go ahead and get the stream from this. And then of course we have the collect function fire away. So in this case, of course, we got the key as a Bob, but the person itself, and Sarah as the key, and the two Sarahs as people. But I don't care about the entire person object after all. So what can I do to get only, let's say, the ages of these people? You know, somebody said it should be a long and not an integer. I love that sentiment. But the point is I want to just collect the integers, the ages of the people. This is where I'm absolutely thrilled about one other capability of the collector. So when you look at the functions in the collector, like grouping by, you gave a function as an argument. But this is the nature of the collector. You can say comma, and you can provide another collector to it. Now remember, what you are getting back from this is a collector after all. Now this is returning a collector, but that collector itself recursively can be formed using yet another collector. So grouping by function, but another collector. Now, honestly, this really intrigued me because I'm a big fan of recursive structures, and I'm able to build a collector using another collector, which in turn can be built with another collector, and so on. And that to me is pretty amazing in terms of how we can build this into the capability we are interested in. So I'm going to say mapping. Now, we know what a map is. If I do a map here, this map is really about all the elements that are flowing through. But instead of the map, we can do mapping. And mapping is happening not in the functional pipeline, but in the reduce stage. So mapping, and I want to map based on the age of the person. So get age, and then I want to put that into a list after all. And that basically says, I'm going to drop that back into a list. And notice now, we have a key, which is a Bob, but the list contains not the people object, but person object, but the ages alone. So this gives a way for us to combine operations together. So you can, and of course, what you saw here was a mapping, which in turn took a function, and then that took a collector. So you can see that recursive nature that I talked about a minute ago. So we said we can pass a collector, but that collector itself happened to be a mapping function, which in turn took a function and yet again took a collector. So we can go through this recursive structure, and as a result, we are able to go from this group, but then we are able to not only do the grouping operation, but the mapping as well. Well, we can take these ideas further, and we can do some other powerful operations, like for example, counting. So what does counting really do? Counting really is where you want to know how many elements exist for each of these. For example, how many of my friends are Bob's? How many of my friends are Sarah? How many of my friends are Brian's? Maybe that's something I want to really know. So then what I can do here is change this to a long, as you can see. And by saying map, string, and long, so tell me how many Sarahs are there, tell me how many Bobs are there, tell me how many Jacks are there. So I can say group based on the name, but then I'm going to say this is going to be counting. And before I run this, let's understand what we are really doing. So what we are doing is, remember what grouping by is. I want you to keep in mind again this idea of buckets. So you are saying, take the person given and drop them into the bucket with that identity. Now you're saying, no, 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 don't drop them into the bucket. Instead, take all the people that go into a bucket, but drop into the bucket not the person, but the count of the number of person in that small part of the collection. So what you're dropping into the bucket is not the person object anymore, but you're actually dropping at this point really the number of objects that are in that particular collection, and you are dropping that at this point. So when you run the code, you see there is one Bob, two Sarahs, one Jill, but two Jacks, and so on. So that gives an idea how we are able to perform the counting. Well, that's great so far. There is one problem though. Notice this is the map of a string and a long. Well, I was working with an application where we have pre-existing code, and the pre-existing code was using a function, we'll call it process for lack of better words, and it was using a count, and it was doing some work with it. Now, the problem was, notice the pre-existing code was using an integer for a count. Now, my little code that I wrote using the collector API gave me long for the counting. And I had to do something absolutely silly, which is to take the map and get the value out of it and cast all the integer longs to an integer and then pass it. And when I write code, some of the code makes me really unhappy. I would write the code, my tests are passing, and I would sit there and say, I don't feel good. This is very smelly. This is very nasty. You know, I would walk away. I'll be taking a walk or I'll be having dinner, and yet this nagging feeling, right? And your mind goes back to that code and says, you wrote that code. Did you really think you can go to bed after writing that code? And you tell your family, I love you, but I'll come back a little later. I gotta go fix this one stupid code I wrote, because nobody wants to go bed knowing they are stupid, isn't it? And that's why I kind of went back and said, you know what? I really don't like it. I gotta fix this. And then I realized, well, we can write an elegant code for that. We don't have to really deal with the mess. So change it to an integer right there. Now, in this case, when I make it an integer, now we get a compilation error after all, because it's a mismatch of API. You can see the compiler is not happy and literally yelled at us. But the problem really is, it says incompatible equality constraint, integer comma long, it says. So what are we going to do? Well, what we can do here is yet another function we can actually use, which is a little nice collecting and then, so which is kind of wicked if you really think about it. So we can then go back and say collecting and then, and you can say counting comma, and then you can say, now that you counted it, do me a favor, just before you leave, just perform one transformation for me, take the long and give me the int value out of that for me. So you're able to perform one more transformation just ever so at the very end. So this collecting and then again goes back to this recursive nature of really, taking this collector and making it out of another collector and yet another one and yet another one and so on. So that gives an idea about how we can form this particular structure. We want to group them, but we also want to collect them. But what we want to put in the bucket is the count, but we want to put an integer value into the bucket. Well, that's great so far, but one of the other things to think about is we sometimes want to perform some operations only during the reduce operation. So this brings back to what is called filtering. But before I talk about filtering, let me just talk about filter and then about filtering. Now, suppose we are told the following. If you're told collect the names, let's say, names of people by age. So we'll take one step at a time. Well, that's easy, right? Because what we can do is we can say grouping by, and we can simply say in here, a person get age. Hey, that's really easy. We can group based on the age. Well, then, of course, if I go back and output that value, we can really see that value being printed, and we don't have to really work really hard for that. So that's basically based on the age of the person, we can get that value. Within the parenthesis, it's a method reference. So you can see the output right there. That was easy. However, what if we are told, collect the names of people by age, but only those older than 30? Now, if that is the given requirement, then what are we going to do? Oh, we can say dot filter, and given a person dot get age, and we can say is greater than 30. And so this is only people who are older than 30. You can see the Sarahs are not there. Jill is not there also, but we have Jack, elder Jack, but not the younger Jack. Well, okay, that's great. But what if the requirement says, collect the names of people by age, but only, not by only, but only those older than 30, and then for younger age. So if we say for younger age, create an empty list. Now, this kind of puts a little pain on us, isn't it? Because for the younger ages, now it's possible that our collection given does not have certain ages. For example, there is no 12, there is no 5. And of course, we don't care about those. But what about 11? You want to say, yes, 11 was there, but nobody was counted because we want to ignore the 11. I know that's a bit of a silly example, but nevertheless, what if we want to do something like that? Well, clearly, filtering is not helping, isn't it? Because filter is not helping. Why is filter not helping? Because filter removes the candidates we don't want to consider, and so collect never had a stab at it. Instead, what you want to say is the following. What you want to say is, create buckets. So this idea of buckets again, drop people into a bucket. We're dropping the people into a bucket, but based on their age. But we're going to say, if a person is below 30, then do not drop them into their designated bucket. So this is really what we want to do to achieve this goal. So once we transform this problem into those words, we can come back here and say, well, here is the person, comma, this is filtering, just to avoid the confusion between filter, which is happening on the stream, and the filtering that's happening in the reduce. So filtering, and when are we filtering? Given a person dot get age is greater than 30, and then comma to list. I want to put that into a list after all and return it to you. So when I run the code this time, notice that we have 32 Paula and Paul, but we have a 3, which is an empty collection. 20 and 22 are empty collections as well. So this accounts for saying, yep, those were present in the collection, but we removed those on purpose, and gives a nice way to represent that. So that is the difference between filter versus filtering after all. And similarly, there's a flat mapping that we could use. Similarly, instead of using a flat map, it's a flat mapping. But I want to wrap this up by giving an example of teeing. So, well, let's go back to what we saw earlier, if you will. So we used nicely the count function, if you notice. We did counting. What was nice about counting? Counting gave us these different age groups and how many people are in that age. That's awesome. Now, on the other hand, we also saw the grouping function. We also saw the partitioning function, partitioning by a function as well. But what if I want to partition But when I partition, I want to know these are two groups, but what I want is the count and not the values. How do I achieve that? So that'll be my last example to show here. So create people.stream, and we'll do a collect on it. Let's output the values right here, if you will. And at this point, what do I want to return from this? I want to return a partitioning by. So I'm going to say partitioning by. And in this case, when I want to partition it, I'm going to say given a person dot get age let's say get age is greater than 30. So I'm dividing this into two collections, those who are older than 30 and those who are less than 30 years of age. So false is less than 30, true is more than 30. But wait a minute, this gives me the collection, but I want the count in each category. Well, don't tell me, put this into a result and then come back and examine it. Well, that's what we had to do in the old version of Java. But thankfully, there's a new function we can use, which is called teeing. So teeing is you take two collectors and you combine the two collectors into one. So you can perform two operations and merge them together. So how would this actually work? So notice what I'm going to do here. I'm going to take this one and I'm going to say over here, filtering, and given a person dot get age is greater than 30. And then I say over here, take that and put it into a list. So that is my first collector that I got right there. The second collector is, in this case, less than or equal to 30. Or if you really wanted to, you could actually put a not off, and then you can put that right there. Because not is a function you can use. I'm a big fan of things like this because it becomes easier to see the opposite of it. So you can simply say import java.util, static java.util function.predicate .not, and you can say not of that. So person and not of people greater than 30 put into a list. Then you say list1 comma list2, and what do I want to return? I want to return a list of at this point. And what am I going to return the list of right now? The list of, let's say list1.size and list2.size in here. So you can return the two list elements sizes. Ooh, that didn't go well. So two list element sizes, and you can return them as you can see. So it gives me an error with the type information of the stream. It was apparently not happy with what I did. We'll figure out what I did wrong here. So this is saying filtering, and I am taking this particular filtering. I want to make sure that I'm in the right place for the closing of the collection right here. So this is finishing the list off. Oh yeah, that's the problem. I need to finish the collect. So this is finishing the collect. No, that's not the problem. And then this is finishing the print line. Okay, so filtering says, given a person, return the person's get age greater than 30, but give it to me as a list, if you will. And that ends the filtering. Then I say, given the person, get me the not of the person right there, and then take that one and give me the list of that as well right in there. Then take these two lists that are given to me, list1 and list2, and return to me a list of, well, in this case, list1 size and list2 size that I want to return from this. And so that ends up with the list of. And then I want to finish the collect and the stream. So I'm not sure exactly where the type mismatch is coming. So probably I can try to put a little type information and see if that helps in here. Or if you find it, you have an extra bracket in the second filtering. I'm not sure if I can see that right there. So if I were to go here, that is really because the to list has to be inside of that. And this one, oh yeah, so let me try not to be smart right now. So let me just get back to that being less than or equal to. Let's copy this and paste it. Maybe that's kind of where I'm causing the issue, trying to do two things at the same time. We never learned that lesson, do we? So let's go ahead and try that again. So run that little code, and nope, still not the reason. So I'm not exactly sure where I messed up. Isn't teeing missing? Yeah, teeing is missing. whoever said that, Martin, thank you so much. You restored, Martin, you restored my faith in pair programming. Thank you. So teeing, right? So exactly. This also proves that I cannot type and speak at the same time, but I tried. So that's the teeing that you're providing right there. And absolutely, thank you for that. So that brings up the teeing, and as a result, we can bring that code in there to collect it. And so as a result, we can see that this brings up the two collections we are interested in. Oh, come on, it's ambiguity, fine. Let's go ahead and put that into a variable. So var, let's say result is equal to, sometimes you just have to please the compiler, right? So let's go back here and say output result and see if it's happy with that. And so we are saying store that variable out there, 3 and 5. Just to kind of go back to the little example I wanted to show you, to put the not to prove that you can do. What a novel idea. You forgot to put the teeing. That is like going to a party and forgetting to take the dessert, right? Okay, so try this again. So run the code again. And right there. So that's an example of teeing, and where you are really saying that I want to take one collector here and another collector over here, and then I want to merge those two into one. You could do a map if you really wanted to here and such. So depending on what you're trying to do, you can proceed with that. So hopefully that gives you an idea about the power of this collector. And teeing is, if I'm not mistaken, is one of the most recent additions to the collector and how that can be used for forming this. So to summarize what we talked about, collector is nothing but a reduce operation. The collector eliminates effort on our part. It eliminates mistakes we would make. It makes the code really thread safe. It provides all these benefits. Well, collectors also gives the ability for us to be very highly expressive. In all honesty, it takes a lot of effort to write this, and especially for people who forget to put the word teeing like me. But once you write it, obviously, it becomes a lot more easier to read it and see what we're trying to do. So it can be a very powerful way of communicating the intent in the code. But on the other hand, it is something that may take a bit of an effort to really get comfortable with. So I've been intrigued by this collector, and so I decided that it's probably well worth just revisiting the collector. I hope you saw things that you already know, but I also hope that you saw some things maybe you haven't really had a chance to explore and look at them as being present. Maybe this gave you an opportunity to go back and expand your depth of collectors. So I'll be delighted to answer any questions, discuss your thoughts, just about anything. I'll be delighted to hear. I think I should be able to keep my eyes on the chat from here on. Things that I've scrolled back, I won't be able to see them, but I'll be able to see anything that's posted now. So that's all I have to talk. I'm delighted to hear your thoughts, your questions, your discussions, just about anything you want to talk about.
That was great. Thanks, Venkat. I think there was one question about debugging within streams. Any tips?
Yeah, so I don't write code with bugs, so I don't know the answer. No, just kidding. There are two answers I want to give for that. The first answer is, if you and I are sitting down together, and if you, if I tell you, hey, I'm writing code in Java, is it really hard to debug? And you say, oh no, Venkat, it's easy to debug Java code. And then I say, oh my gosh, I'm so glad you said that because I'm really having a lot of trouble with this multi-threaded code. And you're going to say, get out of here. Well, what's really hard about multi-threading debugging multi-threaded code? It's not the fact that it's multi-threaded. It's not the fact that we don't have tools. It's the fact that multi-threaded code is non-deterministic, right? So we cannot really put breakpoints and debug the same way. We got to think through the non-deterministic nature. So I got two answers for streams. The first answer is, before we can debug streams, we really need to step back and remind ourselves one more time about the lazy nature of streams. Streams do not evaluate functions. So when you write a filter, for example, the code in the filter or the code in the map, so if you have a filter given here, or if you have a map given here, the code in the filter and the map do not execute until we hit the terminal operation. The minute we know that, we realize you can still put breakpoints in the code and debug them the way you normally do. And in that regard, one of the things I never permit my developers to do is never write a multi-line Lambda. Actually, I'll share with you this experience. I was in London to teach a course on functional programming in Java. And when I came to London, on the Monday I started teaching, they all said, Venkat, thanks for coming. We all hate Lambdas, so you know. I said, that's so welcoming. Thanks for having me here. And I started teaching about Lambdas. And maybe, around Tuesday afternoon or Wednesday morning, I mentioned about a tweet I had written. And my tweet essentially says this: Lambdas are glue code, 2 lines, maybe too many. So that's basically what my tweet was, and a blog post I wrote about it. And I mentioned this, and the minute I mentioned this, the people in the room, I could hear a murmur, and I knew that I ruffled some feathers. And then we take a break, and they leave, and one of the developers said, come over here, I want to show you something. So I walked up to the machine, and the developer said, the person who introduced Lambdas to my team is not in the room right now, but I want to quickly show you this. And opens up the source code and shows me, and every single Lambda was 150 lines or more. And then the developer shows me their automated test coverage. And this company has a culture of writing automated test. A lot of these coverage was green with the red spots in it. And the developer says, go ahead and click on one of those reds. And I click on the red. Every single red was a Lambda. And so then I went back to teach, and I said, let's go over this one more time. Never write multi-line Lambdas. So you always want to write the code, but you want to call the function that you can call from there if it's multiple lines. Well, the good news is if you write this multiple lines, you can debug that separately also. So, and also to write unit tests on them as well. So once we know the semantical meaning of streams and know that it's a lazy evaluation, it becomes a lot easier to debug it. And the last thing I'll mention is if you're using IntelliJ, IntelliJ provides you a really nice way to visualize your stream execution. So if you're using IntelliJ, you just click on a little button and it will give you a dialog where it shows how the stream is being executed. Oftentimes the visual can help us to know, oh, darn it, I got this mixed up in my mind, and you can immediately fix the error. So those are the techniques that have helped me. A, to know the semantical meaning of streams, that they are lazy evaluation. A function will not kick in until the terminal operation is evaluated. B, to never write multi-line Lambda expressions. And C, use things like the stream visualizer and trace the execution of the stream where it may make sense. All right, let's see if we have any other questions here. There
was
Sorry,
one.
Venkat.
Yeah,
I was going to ask one quick question.
Oh, yes, please.
About parallel streams. I mean, is there an anti-pattern to use locks in parallel streams?
Oh, no, absolutely yes. That's definitely an anti-pattern. This is like showing you a cake and telling you never to eat it again. No. So the problem is parallel streams are really intended to parallelize the code, and they have put a lot of effort with splitterators under the hood. And the minute we put the locks by ourselves, we are completely draining the opportunity for true concurrency and performance out of it. So that is definitely 100% anti-pattern. We definitely never want to put locks in a code where we are dealing with streams. What we want to do is eliminate the shared mutability. That is the right answer. You don't want to bring shared mutability and add locks to it. That's definitely 100% anti-pattern. I know you're asking because you probably are seeing code written by developers that are trying to do that, but it's extremely important to lead the team away from that because that's a disaster in the making. What's a good way, oops, scrolled away. So what's the good way to learn Lambdas and streams as well as well, actually, I don't know much at all, honestly. I think that's a very low bar to set. But having said that, one of the things, a couple of different things I would suggest. One is, go through good books. And I use the word plural. I never read a book. I generally tend to read about 7 or 8 books on a particular topic because I really want to soak in different perspectives or different authors. So read multiple books. The second thing is, find a colleague who is really interested in learning as much as you are interested in learning, and then go through some exercises with your colleague and say, hey, let's take these problems, solve them, and then critique each other. The third approach, in my opinion, is, I'm a big fan of this mantra called make it work, make it better real soon. So make it work and make it better real soon. If you can make the code work and then come back and improve it. So oftentimes what I do is I write automated tests and I have an imperative style code passing the test. Then I would sit down and start refactoring the code into a functional style. Often I would find a buddy at work and we would pair together and refactor the code. That's an incredibly nice way to learn. I'll be absolutely honest about it. I want to pair with people because I'm very selfish. I want to learn what they do and how they think and how they do things. And that is, to me, is very wonderful, because anytime I pair with somebody, I come out smarter than when I walked in. And so that's a great way to learn as well. So find code in your own production applications, make sure you have enough automated tests on it, sit down for a couple of hours with the person in your company, and then start refactoring it. I think we learn a great deal. And again, have brown bag sessions, have a Wednesday afternoon, have somebody present a few things about what they are learning in this. That's another way to learn as well along the way. And so let me see if there are other questions here. Will it be easy to maintain such functional code? Well, the functional code is easier to maintain, but only after we learn the semantics. Not just the syntax, but the semantics. The semantics are as important. Once we understand the semantics, the functional code is easier to understand and easier to maintain and easier to parallelize as well. So a lot of times we feel intimidated about what we see because we are not familiar with the code. So if you're finding it rather hard, I'm not suggesting that all functional code is well written, right? I'll give you an example of this. I had somebody email me and said, oh, Venkat, I know you're a big fan of functional programming. I want to show you this code and show that how poor this code really is, even though it's functional style. And I looked at it and said, you know what? You are absolutely correct. It's a really badly written functional code. So I'm not going to argue with you on that. But that's not a judgment on functional style. That's a judgment on how this code was written. And I rewrote the code and I sent to the person and said, what do you think of this? And the person says, how can you write the code so beautifully? I'm like, no, it's nothing to do about me here. It's about just telling yourself that you can follow certain ways of writing code. If I can write code really ugly in imperative style, I can also write ugly code in functional style. My good friend Glenn Vanderberg has, sorry, I'm mixing words here. My good friend Glenn Vanderberg has a beautiful quote. He says, bad programmers will move heaven and earth to write bad code. So you cannot stop people from writing unmaintainable code. So if anybody challenges you, you cannot write unmaintainable code in functional style, we can sit down and show them how to write unmaintainable code. So in any style, we can write maintainable code or unmaintainable code, but the degree is different. So you can put so much effort in imperative style to write maintainable code, or you can put so much effort in functional style to achieve the same level of maintainability, but we got to become really familiar with that. That's very critical. Do we get the recordings of the sessions? I'm going to assume Dom would be able to answer that question.
Yeah, I think it might be available on the YouTube channel, on the LJC Twitter account. So
got it. Wonderful. Awesome. Thank you. So let's see. So what IDE do you normally use for Java? Well, I kind of switch between VI and TextMate and IntelliJ IDEA. So it depends on when you catch me. I am invariably, same source code, I'm invariably switching between these three on multiple windows. I'll open up something and do it on VI because I'm just comfortable with it. I may open something and do in TextMate because it gives me a certain way to manipulate the text that I can do very easily. And then I may be in IntelliJ. So these are three things that I often keep switching. Let's see, what else can we answer here? Would like to have a session on unit testing and automation. Yeah, absolutely. I'll be delighted to be back sometime and talk about unit testing. There are a lot of other talks also on related topics that we can learn from as well. So absolutely. I think I ran out of the questions so far. Thank you so much for all the comments. I really appreciate it. But I'm absolutely willing to answer. I'm not in a rush to run away. So if there are more questions, I'll be happy to answer them. Am I writing a book on Java? No, not at the moment. How do you test multi-threaded code? Unit testing, I mean. Really good question. Absolutely wonderful question. So I struggled with this a few years ago when I was working for a client, and I'm a big fan of automated testing. And I believe this tenet of write, test, and write code. And I sat down to write a piece of code which was multi-threaded, and the devil in my mind said, oh, Venkat, this is really hard. Don't bother, write the code. And so I took it as a challenge, and I asked myself, how can I really unit test multi-threaded code? And what I came up with at that point was that you don't unit test multi-threaded code by running it a billion times. You know, there's this beautiful quote, if you let an infinite number of monkeys type for an infinite amount of time, they can create the work of Shakespeare, right? So it's kind of like that motto is maybe we can keep running this and it'll hopefully test it. So what I realized was you really have to design for testability. And to design for testability, what we really need to do is to quit using the synchronize, because synchronize is totally untestable. Instead, if you really dig a little bit, it turns out the Java 5 API provides a lock interface. And the lock interface contains two methods, a lock and unlock. Because it's an interface, you can override that interface. So what I typically do in my multi-threaded code is I create a stub, and where the lock is needed, I send a stub instead of the lock interface, and then I do the testing with it. One of the realizations is I never want to test my multi-threaded code for whether it is, doing right stuff when you run the code. All I want to test for is that I want to verify that the locks are acquired around the critical sections and the locks are being released properly in the finally block around the critical section. So by using the stub, I'm able to verify the lock acquisition and the lock release properly. And as a result, I'm able to absolutely write automated tests on multi-threaded code. I searched for it. I never could find a talk on this that I gave, but I did give a talk on this topic. I given this in about 2 or 3 places. One was in Norway. I gave this in both the Java user group and the .NET user group over there in Bergen. And I've given this talk actually as part of the Agile conference a few years ago. For the life of me, I could not find the recording anywhere. Maybe that's a topic I have to record someday and post it. Maybe I will do that, because I think there is absolutely a good way to write automated test on it. It's a controversial topic. I've had people who are really angry at me after they saw the talk and they were unhappy with it. But on the same note, I'll be honest about it. I've had people email me and say, I don't like this. But I also had people who come to me 2 years after and say, hey, I sat through the talk and I went off to implement unit testing on multi-thread code in my company, and it changed everything for us. So it's up to the people who want to take that solution or not, but I've used it effectively. I created that based on my work for a client, and from then I learned along the way and realized that we can automate and test multi-threaded code, but by designing for testability rather than just spinning threads to verify that if things are working properly. Let's see if I can see other questions. When should we use a custom collector? I would say almost never. The chances of needing that is so small. I would generally say if you think we need it, we should go call a friend and ask for help and say, get me out of this. I'm trying to create my own. And if it truly is necessary and we cannot really use a combination of the collectors to create it, then and only then we should really create our own collector, not otherwise. That should be really the last option in my opinion. So there are libraries to help unit test. Awaitability is one of them, worth exploring and seeing if they serve your purpose. How do we start adopting functional programming? Well, first of all, one of the key things about functional programming is that it is actually declarative in nature. So a lot of times we are trying to make the code functional, but if we pause and ask about declarative style, then think declaratively and code functionally. So in other words, in the imperative style, we focus on how to do things. In the declarative style, we focus on what we want to do. And I don't know if you noticed earlier, I wrote down in words and then I started writing the code for it. That is something I do quite a bit because the declarative style helped me to think what I want to do. Then I find functions that can do that. So taking the route of declarative and functional often seems to help. The other approach, of course, is what I mentioned earlier. Start refactoring code, find somebody to pair with, have them review, and that way you can bounce off ideas. That's a really good way for us to really learn from each other as well. The Sql and Stream Api look very similar. It's tempting to run, so it's not such a coincidental thought. You are absolutely correct. In fact, the functional API is kind of like SQL query on the in-memory data. This is why C# did not introduce Lambdas. They first introduced LINQ, and LINQ is literally the SQL query API of data in memory. So Java went the route of Lambdas, whereas C# went the route of links, and then they generalized it to Lambdas. So what you're saying is so true that it's really a reflection of the SQL-like kind of query, because SQL is declarative and functional is declarative. That's the reason for that. Let's see if there's more things here. In companies, we normally start with the Spring, and I am a .NET developer transitioning to Java, and I learned that we do well in Java. I need to learn Spring. So now I'm using Reactor and Webflux in Spring. What is the best way to learn reactive programming in Java to understand that reactive HTTP works underneath? Spring is great. That's wonderful. But in general, though, it's really important to step away from the libraries and frameworks and truly understand the concept. In terms of reactive programming, to me, reactive programming is really functional programming plus. It is really taking the stream and applying lazy evaluation on it. And so to me, when I was struggling with reactive programming, right, trying to put my head around it. And one day I just jumped out of my seat and I wrote down and said, oh my gosh, reactive programming is functional programming plus, because you're applying lazy evaluation, you're applying the stream processing. So all these things we do in functional programming readily maps over to reactive programming, with the difference that reactive programming raises the level of abstraction. It gives you the 3 channels I talked about earlier. So as the stream of data flows through, you are going through the data stream or the error stream or the complete stream. So I would say look at libraries like RX Java. RX Java shows in very simple terms, without the clutter and without the noise and without the frameworks and set of libraries around it that you have to carry through. I'm a person who likes to remove all the clutter away from me and just focus on the essence. And RX Java did that for me. So take a look at RX Java and see how reactive streams are implemented in that. Write some samples, very simple examples. Write a main with only RX Java in it and see how it works. And once it clicks, then you can go back and use Spring or any other libraries, doesn't matter. And you should also be able to switch between libraries as well. So go to the fundamentals, go to the minimalistic solution that can help us quite a bit in getting a fairly good view of what these details really are. A couple of more things in here. Let's see, difference between functional reactive and, oops, that kind of scrolled away, I apologize. Difference between functional reactive and functional reactive programming. So to me, the abstraction really is that reactive programming is really a concept built on top of the functional pipeline. So in functional programming, we have two concepts, right? The functional composition, the functional pipeline, and the lazy evaluation. Reactive programming has both of those. And it's really raising the level beyond it. To me, calling it as a functional reactive programming really is redundant, because to me, reactive programming is functional programming in that context. So it's really raising the level of abstraction. Reactive APIs show us ways to deal with errors in a way as well. So it can actually inspire us to go back and do reactive programming in a lot better way. Can you name some parallel stream perils, performance or other related that are known workarounds for them? Well, one of the problems with parallel streams really is when you create a parallel stream by default uses the common thread pool. Now, if your parallel stream contains computation intensive job and IO intensive job, they're competing for that pool. The performance is going to be a problem, absolutely. Then you have to start creating your own pools. And if you start creating your own pools, you have to then say, this pool needs to be for computation intensive. That pool is going to be for IO intensive. And you got to start configuring the threads in it. Complexity eventually creeps in when you start doing it, right? That's one of the problems. The second problem is parallel and lazy don't go together. When you do lazy evaluation in functional programming, you're saying, do minimalistic work. Don't do anything that's not needed. Parallel is fire on all cylinders. Run as much code as you can. I don't worry about wasting computation with the hope of getting the results faster. That's another problem you have to deal with. Third, the results are non-deterministic. If you care about ordering, you may not get ordering depending on what kind of functions you are using. So these are the three things to think about, but there's a lot more to think about as well. And so we got to be very careful about it. What's your approach to learning something new? So one of the things I've realized over time is we as humans learn in increments, and we learn in delta. So if you come to me and say, you know this, and I want you to learn that new concept, no problem, I got it. But if you come to me and say, you know this, but I want you to learn that, I'm like, sorry, I'm not capable of doing it. So one of the key things about learning is to learn incrementally. And the deltas add up very quickly. In a way, I often say, it's a lot of things what we do is like climbing the staircases. You climb 1 stair, 2 stair, 3 stairs, it's not much. But then 20 stairs later, you are on another floor altogether. That incremental change is extremely important. I actually have learning disability. I cannot learn effectively compared to a lot of people I know, but I found ways to compensate for my deficiencies, and I learn incrementally. One of the other things also is a bit of a privilege, but some privileges are not given. Some privileges are what we work to acquire. So one of the privileges I work to acquire is I get to learn what I am curious about. So I get to decide things I want to learn and things I don't care as much to learn about. So, and the reason I say that is, if we are absolutely curious about something, we're going to put everything into it. You know, I say my job is a kid in a candy store. I wake up in the morning and literally, I don't need an alarm to get up. I want to run because there are things I want to experiment, things I want to tinker with, things I want to learn, because I let my curiosity lead me towards it. On the other hand, if I'm forced to learn something, I'm not going to be good at it. So you know, find things that you are genuinely curious about. You know, my friends are great in areas, but that doesn't really excite me. The areas that excite me are different from the areas that excite my friends. And that's one of the reasons why I like to tinker with things that they may not care about, and they like to tinker with things I may not care about. So find that, you know, thing that gets you get excited, gets you out of the bed and say, I gotta go tinker. Then we end up actually learning more effectively when we find those things that are curious and want to poke around. The next question here is, could you please do more talks on Spring? You know, I normally don't do much talks on libraries as much. I don't do a lot of talks on Spring or Hibernate. That's, again, this kind of goes back to the curiosity and the passion and the liking, isn't it? So my desires are really tinkering with languages, tinkering with thinking about design, thinking about architecture. That's the line of focus I generally have. You know, I talk about reactive programming, I talk about functional programming, I talk about languages, I talk about adopting languages, I talk about design, design patterns, and architecture. That's the kind of area that gets me excited. And, you know, even though there are so many libraries and people use those libraries and frameworks, that often doesn't get me excited. That is not to say I never do those things, but they're fairly minimum. You know, I do sometimes talks on React or Vue or Angular, but generally speaking, I try to limit them. I don't want to get dragged into doing too many of those because, you know, things that excite me are not those kinds of stuff. I get excited about different sets of things. And honestly, like I said earlier, I'm very selfish. I'm going to be doing stuff that excites me, not the stuff that others want me to do, right? So that's kind of what I focus on is when I do things that I'm really excited about, I tend to really, you know, feel satisfied doing it. Otherwise, it becomes like, gosh, I got to do this because somebody wants to do. And that's kind of one of the reasons why I work really hard to get rid of my boss. And, you know, when you don't have a boss, you don't have to do stuff they want you to do. And it has pluses and minuses, right? So, and that's kind of the things that drag you around your life, is to decide what you want to choose. And there's no absolute truth to what we do. It's all a trade-off. It's all a compromise, right? Having a good company to work for and being told what to do has merits to it. But it's got, you know, consequences too. You got to drag your feet and do stuff they want you to do. So it's a combination of things we have to deal with every day and pick and choose that, unfortunately. Any other questions or comments before we wrap this up? What are the thoughts on other languages on the JVM? Do they have a future or destined to be always a niche? Oh, they definitely have future. They already have the future, in all honesty. Just as one example, 75% of Kotlin, sorry, 75% of Android development is on Kotlin. So languages do have a really good future. Maybe we may argue that you know, Android is not JVM, but the point is Kotlin is a multi-platform language. Spring folks have put in a lot of effort into Kotlin as well. So a lot of people who are using Android are also using Kotlin for doing development on the JVM as well. But also I want to emphasize one thing. I have the deepest respect for a lot of these languages for a couple of different reasons. I often say the contribution of these languages are that they truly push the boundaries. I mean, think about where Java is today. I'm not by any means suggesting that Java is copying from these languages. I don't want to put those words into my mouth. That's not what I'm saying. But developers of Java are truly looking at these languages and asking the question, did that work effectively there? That's an extremely valuable information for Java, because Java does not have the luxury of introducing a feature and removing it. These languages on the JVM are doing a great service to Java because they are providing things, and Java as a language being developed can look at this and say, that didn't work really well, we shouldn't even go that route. Well, that worked really well, but that's not feasible on the JVM, so we won't do it. Oh, that one worked really well and is feasible, so we should definitely have that, or we use it. So that is basically the benefits of these languages, and we cannot take that lightly, right? So that's a very, very huge contribution these languages are doing, and I have the deepest respect, and I'm very thankful for the developers behind those languages, because those developers of those languages are really pushing the boundaries for languages like Java. And so we should be very thankful for that. So they have very important future ahead. And that's definitely not a niche in that sense, in my opinion. Is it possible to master or learn properly a language or technology without working on live projects where we use it? Well, I have a strong opinion about it. And that is, I think somebody has to be somebody who uses a language but never teaches it is not effective. And somebody who teaches a language but never uses it is not effective. And that is one of the things I always tell people: use what you teach and teach what you use. I can tell you how many times I go to companies and I would be sitting with developers and they would be using a language on their production software. And I would tell them, why don't you use this way? And they look at me, it's like, what do you mean? Well, we can do it this way. And they would say, I never thought we could use it that way. Well, that's because you never really taught anyone to use it. So you don't think about how it could be used. Teaching is a very powerful tool because you're sitting and exploring different ways to express an idea, and you're thinking about how to really design something and convey that design. So don't use what you don't teach, and don't teach what you don't use. So I think to be an effective developer, you have to do both. So you don't want to do one and not the other. So, and again, one of the reasons I teach is I can learn as well. So you don't learn by doing alone, and you don't learn by not doing either. So it's a combination of both we need to really do. Thoughts on Graal VM? I absolutely am delighted to see the development in Graal VM. I think that's going to change a lot of things. It's a little too early in a lot of respect, I think, but I think we should definitely keep an eye out for it. A lot of things are changing in Graal VM as well. So definitely it's going to be, well, it's a polyglot environment. So all merits to it. Definitely there is a lot of exciting stuff going on there. We should definitely keep our eyes open for that. One of the comments here is, I heard that bad teachers or presenters can be replaced by a good book. Presenter mission is to motivate instead. You are exactly that, Vector. Oh, thank you. I was hoping a question there. Thank you. I really appreciate it. Well, actually, I want to say one thing. You kind of brought up a topic I've been thinking about for a while. I actually, having written a number of books myself, I would say reading a book is necessary but not sufficient. And the reason I say that is, when I read a book, I'm absorbing the concepts. I'm getting exposed to the ideas. But where I really learn is when I write some code and be critiqued about it. So I write something, a colleague critiques me, and then I am looking at various different options. So I would say a book plus presentations plus being our code reviewed and having a buddy to pair with, all of those are very effective ways to learn. And I want to really exercise all those channels in general to be able to benefit from that, I think. If there is a new requirement for a web-based application Should we use Kotlin or Java, or recommendations are on both to coexist? My honest answer and absolute sincere answer is I don't know, because I need a lot of context to decide on what languages to use. I've created quite a number of greenfield web applications myself, and I go through that motion every single time. I never start a project saying, I know this stuff, I know what to use. I go through a due diligence to decide what languages and libraries I'm going to use, and I never take that decision lightly. So I think we need to really spend more time and exploring the context and details to make that decision. If there is no live project, we can create one, can't we? That's the core of actual learning. Yes, but also there are live projects. You can find open source projects and start contributing to that. You could write documentation on the projects. You can fix bugs. You can even report bugs. You know, I've done that quite a bit. I would report bugs on projects rather than doing anything else. They got the smartest people in the world to fix the bugs. But you know what? I was playing with it. I ran into a bug. I report bugs often. And that's a really good way to learn, because when I submit a bug report, I get a response back from them. I get to dig deeper into it. And I always come out learning more about the tool and the framework by reporting bugs than I did before. And I go back to see how they fixed it. That's a great learning experience as well that can be very useful. One of the comments here is there any future for Java at all, especially with advent of Kotlin, and also all the bad things about Java? Is there a future for Java? Totally, totally, totally. I could not argue more for the future of Java. Java's future is pretty darn strong. And the reason I say that is Java is a very respectable language. Java is verbose. That's the nature of the language. But over the past few years, Java has significantly evolved. It is low ceremony now compared to it was before. Look at the developments in Java in recent times, the pattern matching that's coming up, the text blocks, the ability to write switch expressions. But of all the things, Project Loom is something I'm eagerly waiting for. So I was the guy on the other side of the picket line complaining Java sucks, but that was before Java 8. Now I'm one of the biggest fans of Java, but that doesn't mean I use Java and nothing else. I use a lot of different languages. I will continue to use a lot of different languages, but that doesn't mean I have any less desire to use Java or respect for it. I go to companies, I'm a consultant. I go to training, consulting, mentoring. When I go to companies, I tell them, I will never tell you you have to use a different language. My goal is to make you better in what you do. And along the way, if you have options for other things, we'll evaluate it. So I work with a lot of companies doing very deep Java development. And I go work with them and make them better at doing Java. So my goal is never to say, this language is better than the other and you should quit using it, because that's not a very good recommendation, in my opinion. It is really looking at what we can do better in the languages and tools we have with us, and then make decisions based on the true context, based on the relevant context that we can look at. Which of the following Java features do you think will provide the biggest impact for the language? Well, that's really hard to say, because it depends on the users. But personally, I am putting a lot of faith into Project Loom, because I think fibers and continuations are going to make a difference. That's just my opinion. That's what I'm really getting excited about. Any recent book you have read that you heavily recommend? No, I don't really generally recommend things as much. Recommendations are things I try to avoid as much as I can for various different reasons. I keep reading stuff from time to time. I actually more of a tinkerer than a reader personally myself. I do read quite a bit of non-technical books. Technical books, I kind of read based on things I'm just curious about, but usually I kind of keep churning through things. But I do admit, I am not a person who reads books cover to cover. I just don't have patience for it. I'll be absolutely honest about it. I'm probably the most impatient person I know. So I would jump in, start reading a book. I will jump around a book. unless it's a non-technical book, motivational book, I might read it cover to cover. But technical books, I often jump around a lot and read bits and pieces. But my usual formula is 1 hour of reading and 10 hours of coding. So I would open a book, I'll start reading, I would have read half a paragraph, and then here I am 3-4 hours later, still writing code. And then I would go back to like, oh yeah, I remember, let me read a little bit more. So I do read books, but not in the traditional way of back-to-back reading. That's one of the reasons it's hard for me to recommend books as well, because how could I recommend a book I've not read cover to cover? So I kind of jump in and jump out of books a lot. But having said that, I also read quite a number of books these days, which are pre-publication. So publishers contact me and say, hey, we're writing a book. Would you like to review this book? And if it's a topic I'm interested in, if it's a bunch of authors I either know have interacted with before, or genuinely it's a topic I really care about, I jump in and start reviewing the books. In that case, of course, I read cover to cover because I'm reviewing the book. But those are the books I tend to read cover to cover these days in general. Probably one or two final questions. What's your advice to trainers who don't have opportunity to work on live project? We always do, right? When we have a desire, we always do. We can find open source projects. There are so many open source projects. We can start contributing to them by reporting bugs, documenting them, writing test cases to fortify their test, and then start producing features. And so we can gradually ease into open source projects. Secondly, there are so many things we can create. That's one of the things I do. When I start learning something, I never learn about it. I always go create something. So I would look around my own work and say, what are the tools missing around me? What are the things that are not available around me that I could potentially create with this technology? And I would go off and create some of those. So I always create pet projects that will help me to get deeper into things. I remember this one experience I had. I was really not familiar with a particular library, and we were working using a database at the time, and the database had a very poor user interface. And this was a UI library. So I wanted to learn it. So what I did was I gave myself 8 weeks. And I would start very early on Saturdays. I'm a person who likes to really devote time. And if I committed to something, I'll pour everything into it. So I would start like 3 a.m. on Saturdays. And 3 a.m. to 10 a.m. is a great time on Saturdays, because by around 10 a.m. family wakes up, they want you. So I would wake up several hours before the family wakes up so I can have undivided time. So I would spend 3 a.m. to maybe 6 a.m., whatever, learning and tinkering with code. And then I would switch gears, and whatever I learned in the 3 to 4 hours, I would just code parts of the application I was developing. So I did develop the UI for the database that we were using. And then I quietly put it out in the company that I was working for, and people started using it, never told them who created it. And a few months later, the vendor comes around and says, hey, we want to look at what you guys do. And somebody said, hey, this particular tool you guys created is awesome. We've been using it. And they were like, what tool are you talking about? And one of the person demos the tool, and they're like, that's not from us. Well, gosh, then where did this come from? And then eventually they came back and said, hey, who created this? I'm like, yeah, I created it for learning. And the database vendor wanted to pay money to get it. And I pretty much gave it out free for them. I'm like, I'm not interested in making money from this. I just built it for learning. So I tend to do that quite a bit. I would create stuff as a way to learn as well, because that gives a rigor into learning things. And that's really a nice way to proceed also. So that is something to really think about. How many books do you typically read in a month? That's really hard to say, because it varies quite a bit based on things I do. I am probably one of the most irregular person I can think of. I don't usually say that's my goal. I work very long hours. So the amount of time I actually spend time reading books per se is rather less. So it's really hard to say. I don't have an average to report. Some months it could even go to 0 because things are so hectic and busy. And other months I may read 2 or 3 books. So it depends really on what I'm doing. I got a lot of open books than books I've completed reading, so it's really hard to measure the number of books. I'm not one of those people, I'll be absolutely honest about it, who will give you a list of books and say, those are the books I read. That's not me. Different people learn differently, and I'm not a person who learns by only reading books. I learn very differently than others do, and that's exactly the point. You got to find the way that you learn. If you're a person who learns by reading books, kudos to you, continue doing that. But I'm not going to pretend to you that I learned by reading books. I learn by doing, so that's what I do. I spend a lot of time tinkering with code, writing code, breaking code. I learn by creating things and breaking them and putting them back together. That is my mode of learning. I mean, I mentioned earlier that I come from a learning disability. So what works for other people has never worked for me. And so eventually I realized that I can fail doing what they do or find a way that makes me successful. And that's what I've done. Any other questions or comments? What is Scala best used for? Well, Scala is a very powerful language. It really brought in a lot of functional style of programming onto the JVM in the early days. But a lot of strengths of Scala are the way it's able to handle, for example, concurrency. Scala is a very highly concise language. So a lot of things that are in Scala are done very powerfully that would take a lot more effort to do in language like Java. So if you're dealing with an enormously concurrent application, it's very well worth looking at Scala. I actually worked with a client who has been doing a lot of concurrent code, was having a lot of difficulty with Java, and realized that they could switch over to Scala and get the benefits out of it. So Scala is great for that. Scala also has capabilities for working with various things like XML, for example. So if you have code that needs to do significant pattern matching, we know that Java is coming up with pattern matching, but Scala has had it for a long time. And you can process different types of data, which means if you're receiving messages from arbitrary sources, you can do really nice message processing with Scala as well. So there's a lot of different benefits that Scala offers. And if you're curious about it, look at what folks at Lightbend are doing, and their Akka product and how reactive programming is being implemented on Akka. Akka is a product written on top of Scala, and that would be a good inspiration to look at. How about learning using websites to help? Absolutely. Don't let anyone stop you from learning. Find your way to learn, right? I never went around asking people what's the right way to learn. I just started learning, right? That's the whole idea. We should never, ever, find what others do and think that it's going to work for us. That's one of the things I want to really emphasize. The biggest way to fail is to assume what worked for somebody else is going to work for us. I always figure out what works for me, because I am different from others in my own flaws, right? Not in my own capabilities. I've got quite a bit of disabilities I have to tackle for myself. And how foolish is it for me to say, hey, that's the way you learn, so that's the way I should learn. So that's why I'm very reluctant to give these recommendations in general. When people come to me and say, what do you recommend? I'm like, sorry, I cannot recommend, because that is so naive of me to assume that this worked for me, so it should work for you. I'm sorry, that's not the way it worked for me. A lot of things that work for others never worked for me. So I had to really go struggle and sit down and think about this and say, my gosh, why doesn't this work for me? And then realize that different things work for me and go off and figure those out. So you have to really take the journey and figure out what works for you, and then exploit that to the maximum, rather than trying to say that, this is the way to work. I mean, we try to put people into a box oftentimes, right? We say, this is the way to do things. No, it's not. You need to figure out what works for you. That's the key. Could you give any tips on getting the first job as a junior Java developer? Well, we live in a world where I truly believe networking is extremely important. This is not nepotism, right? This is not where I sneak you in because you're my cousin, or I sneak you in because you're my nephew. That's nepotism. Networking is where, as a professional, you know people in the community. And I'll tell you something that blew my mind. This is one of the absolute, I'm thankful for traveling around the world. I have come across user groups around the world that are run by students. And I spent, 3/4 of my day with my jaw on the floor, listening to these students. And I always tell them, you're running a user group when you're a student. I want to know where you're going to be when you graduate. So that's my first thing. Go to user groups. I always tell one thing. It's not whom you know that matters. It's who knows you that matters the most. So if you know me, it doesn't matter. Because if I have a job and if I'm a manager, I'm going to call you only if I know you. So the point is, you need to, and again, I don't want you to take this as a manipulation, right? That's not the goal. But the goal is you need to really become prominent in your community. So in your user group, when I was, in my town, I would go be part of the user groups, and to a point where people in the local software development community should know me by name as much as I know them by their name. And that is extremely important. As an example, this reminds me of one story I would never forget. I had a VP of a company who was going to make a very important hire. And I'm walking into the company to have a meeting with this VP, and I can see the VP over there, and I'm approaching. And as I'm approaching, I hear my name, hey, Venkat. And I turn around, look over there, and there was somebody that I could recognize from the local user group. And I said, hello. And I walk up to this vice president, and he says, hang on a second. And he says, do you know Venkat? And the person is like, of course I know Venkat. Oh, I've seen him in user groups. And the VP says, 3 o'clock, my office, you and I need to talk. And I was like, this deal is done already, right? So the point is that when you know somebody inside who has seen you and seen you being effective, that's what you really want. You don't want to go through that resume. You don't want to be going through that process. You want to cut across because they know you, they've seen you, they know that you communicate really well. They know that you have strengths, and they want to hire you because you're going to be there to enhance their reputation. And that is the key. And it doesn't matter whether it's the first job or if it's the second or the 50th job, it doesn't matter. I'm not being arrogant. I want to emphasize that. I knock on the wood. I'm very humble for this, but I've never made a single sales call ever. I never wake up in the morning and send an email asking, can I come and work with you guys? Can I do something, right? Every single opportunity I get is because people call me. And that is the whole thing. You want to spend your time networking. You want to spend your time showing people that you are capable of doing things. And so improve your reputation. Let the job find you rather than you finding the job. I know that sounds so weird, but that's an emphasis I want to place. Don't ever look for a job. Let the job always look for you. And so you focus all your effort on really learning, really becoming better at what you do, and network and become prominent, become prolific. Let the job find you. I've seen this among people that I know. They get out of the school, and before they do, they have companies calling them because they've been blogging about it. They've been writing books on the topic. They've been part of user groups. So be prolific and be part of a network, and then let that lead you along the way. So one more question probably to wrap this up, probably a good time. So not a question, but a comment. Absolutely. So let's take a look at that. If there is no opportunity to use some new language at work, we can create these opportunities ourselves. Totally. I could not agree more at all. We can create websites, mentor people, do hobby projects. Totally, right? I could not agree more. There is absolutely. So you know what? This is the funniest thing, right? When I was a student, you're probably going to laugh at me when I say this. When I was a student, there was no internet, right? My children always look at me and say, gosh, what did you do with the dinosaurs, Dad, right? Well, there was no internet. We live in a completely different world. We have a global connection of people, and there's only one thing we need, in my opinion. That is our genuine desire to do something, right? That's it. And if we have the genuine desire to do something, nobody can stop us. And that's the fun part, right? I mean, I'm here in my basement right now standing, and from a basement, I can do just about anything I want to do, nothing to stop me. The only thing needed is that motivation, right? And as long as I feel like I have to do it, nothing to stop me. And that's the whole idea. So to your point, absolutely, I could not agree more, Nikita, absolutely, nothing to stop you at all. So if you want to learn it, go for it. Anything you want to do, create your own projects, create your own websites, mentor people, talk about it, write blog posts on it, and write automated tests on stuff. That's a great way to learn. Absolutely nothing to stop us. So that's kind of where I'm going to stop and yield back to the organizers. If you have announcements to make, you can take that forward. I really want to thank you all for taking the time and spending the time with us here. I couldn't be happier. I want to wish you all well. Please stay safe. And I hope to be there one day in person so I can give big hugs to everybody there and be part of the in-person meeting. Thank you.